Welcome to Klein's Geometry. Today
We're going to look at lesson 3.5,
slopes of lines. This is a review from algebra, but you'll find out when you put it all together, sometimes you see the big picture, it cements it more firmly in your mind. So our objectives for today are to find the slope of a line and use slopes to identify parallel and perpendicular lines.
okay?
We're going to skip the warm-up. The three big words are rise, run, and slope. If you think about a coordinate plane, the x and the y-axis, the x-axis runs horizontally while the y-axis rises. So when we measure slope, which is just the slant of a line, say we've got a slant here, what we want to know is as it goes along the horizontal axis, we measure this distance, the change in x. How far up did it go? The change in y. And that little triangle means change. So slope is simply that change in the y value over that change in the x value. And to find the change, we subtract. Hence the slope formula. So the slope of a line on a coordinate plane is just a number. It describes the steepness of that line. And any 2 points on the line can be used to find the slope. You get the same slope no matter which 2 points you use. So the rise, take a look at this. If you look at this line, the rise is going to be how far up it goes, the run how far over. And we're always making a right triangle to see how that works. So in this case, and you can count it out. You can use the slope formula, but if you're on a coordinate plane, just count it out. Rise, 1, 2, 3, 4, 5, went up 6. 1, 2, 3, 4, 5, 6. So slope is 6 over, went over 1, 2, 3, 4. So 6 over 4 would be our slope, and we can reduce that to 3 over 2. Notice if you just look for like this point, which is on a little crossing, and you look at this 2, see right here, up 3 to the right 2. So there's our slope. Up 3 over 2. Up 3 over 2. And you can find all kinds of points on the line using that process. Now, to use the formula, which is just our change in y over the change in x, it says use it to find the slope of line AB. Well, I see right here is line AB. Here's a point, and it's -2, 4, 5, 6, 7. So A is -2, 7, and B is 3, 7. And to find the slope, which is always denoted with an M, I'm going to take my y values, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I just think, okay, here's my first point. And I just label them x, y, sub 1, sub 2. 7 minus this 7 over 3 minus this -2. Well, anytime you've got 7 over 7, you got 0. This is going to be 5. 0 over any number is 0. So that's got a slope of 0. In fact, all horizontal lines have a slope of 0. The only thing these equations have in common is the y value will always be 7. So the equation of the line is y equals 7, and the slope of the line is 0. That's all horizontal lines. Now we want to find AC. So now we're going to look at this line. Once again, A is -2 and 7, and C is 4 and 2. And another nice way to look at this, if you think about this as x1, y sub 1, x sub 2, y sub 2, you can see these, for my slope, I can just cover this up and say 7 minus 2. The second coordinates go on the top. And here I'm going to put -2 minus 4. So I've got 5 over -6, and there's my slope. Now if we were to count that, we'd say from here down, because it's negative, 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6. And we see we calculated it correctly. So rise over run, and if it's negative, we're going down. Okay? Oh, And one other thing to note, if you could have the negative in the numerator or the denominator, depending on which way you did it. Here, they notice their work, they put the 2 first instead of the 7. But then the 4 had to go first instead of the negative 2. You can go either order, doesn't matter. You'll get to the same place. They got a negative on the top, whereas I got it on the bottom. Either way, you can have a negative here, you can have a negative in the denominator, you can have a negative in the middle. Just means the slope's negative, line's going down. Doesn't matter where the negative falls. AD, now this is another interesting one. We'll look at that. We're going to put in negative 2, 7 for x sub 1, y sub 1, negative 2, 1 for x sub 2, y sub 2. And when we do that, we have 1 minus 7 is negative 6, but negative 2 minus negative 2, there's a negative here, is 0. And if you've got 0 in the denominator, well, you know you can't do that. Math police will take you right away. That means the slope is undefined. So anytime you have 0 in the denominator, slope is undefined, and that's a vertical line. And you notice what they've got in common is the negative 2. So the equation of any vertical line is going to be x equals, and it's whatever this constant is, in this case negative 2. So that's the equation of that line. All the points on it, x equals negative 2. And the slope of the line is, we call it undefined. Now remember, a fraction with 0 in the denominator is always undefined. It's impossible to divide by 0. If I were to take this group of 3 and say, divide this into groups with 0 in each group, you can't do it. That's why you can't divide by 0. That's why we would call that slope undefined. Okay, so now what about CD? Well, you can see that, rise over run, up 1 to the right, 1, 2, 3, 4, 5, 6, which gives us a slope of 1/6. And you can use the formula to get that also. Now, if you're just given points, maybe you aren't given a graph, now you're forced into using the slope formula. I would, to avoid error, take K and put it under J, and I've got x sub 1, y sub 1, x sub 2, y sub 2, and I can see to find my slope, I'm going to do 1 minus negative 1. There's 1 in the formula, negative 1 there, over 3 minus 2, minus a negative, I end up with 2 over 1. So my slope's going to be 2. And you can do it that way too. You can always do it that way. Just remember, the second coordinate goes on the top in the slope formula. Summary of that. Positive slopes. You're always thinking left to right, just like you read. If it's going up, it's positive. If it's going down, left to right, it's negative. Slope of 0. Just like the floor doesn't have any slope. It's even. Slope of 0 is horizontal. Undefined slope is a vertical line. There's no way you can talk about that having any measurable slope. It's just straight up and down, undefined. Okay? So when we think of slope, we think of it as a rate of change, which gets very important when you get into higher math classes. So how fast is something changing over time? And it could be your paycheck's changing, it's going up however many dollars per hour you make every hour. Your miles traveled over time, how many miles per hour you went. All kinds of things that can change. Water might be draining out your pool at so many gallons per minute or hour, depending on how slow it is. So here's a rate of change application. Justin's driving home from his college dormitory. At 4, he's 260 miles from home. I like to underline important information. And at 7, he's 455 miles from home. We want to graph the line that represents his distance from home and interpret the slope of the line. Well, you can make a graph, and since we talked about hours, we're going to put time here, hours, time in hours, and here we have miles, and it's important to know what's on each axis. And at 4, we are 260 miles, so notice we're going by hundreds here. so about here. And at 7, we're at 455 miles. Now we can just plot this, and now we can graph it because we can just use our slope formula. 455 minus 260 over 7 minus 4. And we see that it's going an average rate of 65 miles per hour. So, easy way to do those kinds of problems. Remember, if they give you a time and a distance, you have an ordered pair. Okay, now let's talk about parallel lines. Parallel, when you think about slope being steepness, if they're parallel, they're going to have the same slope. So, vertical lines, they're all parallel. Straight vertical, straight up and down, straight across. Horizontal lines, they're all parallel. And they can have the same slope, the same steepness, and be on a slant too. Perpendicular lines, they have a slope whose product is -1. That means they're opposite reciprocals. And examples of perpendicular slopes, if the slope of one line was 2 over 3, it went up 2 units for every 3 to the right, then a perpendicular slope would be, let's make it the opposite sign, this is positive, we'll make it negative, and the reciprocal fraction would be 3 over 2. So an opposite reciprocal, these two slopes are opposite reciprocals, so any two lines with those two slopes would be perpendicular. Also vertical and horizontal slopes are perpendicular. Okay, if it's line, and if you want to think about it in symbols, if a line has a slope of A over B, one number over another, the slope of a line perpendicular to it will be B over A, opposite signs. And you can think of this as the opposite sign is to become negative. Okay? And so remember that 4 given points won't always determine 2 lines. You have to graph the points to make sure those lines, that all these points are not the same line. Okay? So it says graph each pair of lines and use their slopes to see if they're parallel, perpendicular, or neither. So I have line UV, U is 0, 2, and V is -1, 1. So those are the 2 points I've got to plot and put on this. And then I'm going to have, and I'm going to connect them to form a line. And then XY has points X, 3, 1, and Y, -3, 3. So I plot those, and I see, here is UV. And here's XY. And just looking at them, they appear to be perpendicular. You know, perpendicular if you can put a corner in there. But you need to check them. You need to use the slope formula and make sure they're opposite reciprocals. So UV, and you need to label them too when you're doing your work. Tell me the slope of UV. And you're putting in -1 minus 2 over -1 minus 0, and you end up with 3. Then you find the slope of XY. 3 minus 1 over -3 minus 3. And you get -1/3. And if you think about 3 over 1, because anytime you got a whole number, you can put 1 under it, and -1 over 3, they are indeed opposite reciprocals, so you say they're perpendicular lines. And that's part of it. You have to say that. This is the answer, because it says graph them. That's the first thing you do. Then it says use the slopes to see if they're parallel, perpendicular, or neither. Well, you find the slopes, and then you need to analyze this. You need to look at these 2 answers you've got, make a conclusion, and state it in a sentence. The product of the slopes is -1, so the lines are perpendicular. So make sure that you're doing that. Okay? Doing the same thing again. Notice these don't appear to be either, but again, you check them, you put your points into the equations, you say 1 and -2. Well, they aren't the same, so they're not parallel. They're not opposite reciprocals, so then you'd say they're neither. They're just plain old lines that cross. So, not parallel, not perpendicular, neither. You look at these, they appear to be perpendicular, but looks can be deceiving. So again, we check them. We use the slope formula. And when we do, we get the same slope for both lines. So now we can say the lines have the same slope, so they are parallel. Okay, and we aren't gonna, oh, and one more, let's look at these. They look perpendicular, you got horizontal, you got vertical, you check them, you see it's true, so you say they are perpendicular. If it's horizontal and a vertical, you've always got perpendicular. Okay, and we're just gonna go through these. Summary. Slope is simply the slant of a line, calculated by the ratio rise over run. Or, as I showed you in symbols, slope equals the change in y over the change in x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Vertical lines, they always have the equation x equals a constant, and the slope is undefined. Horizontal lines have the equation y equals a constant, and the slope is 0. Parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. On your notes, I should see something of each of these examples and the summary. See you in class.